Okay, so yesterday we have seen uh, some of the points related to 8085 microprocessor. We will be continuing that subject and we will be moving forward to summarize the first unit of microprocessor, where we will be learning about some more new terms like what is BIU and EU and more terms like that, and we will also see the key differences between 8085 and 8086 microprocessor along with a pin diagram of 8086 microprocessor. So let's move ahead without wasting any more time. So first of all, we have seen what are microprocessor. So let me revise you what is microprocessor. From the previous video, we have discussed a microprocessor is a central processing unit on a single integrated circuit chip. Okay, so it executes instructions from a program and performs arithmetic, logic, and control and input-output operations. Microprocessors serve as the brain of the computers and many other electronic devices. Okay, now let us move ahead with some history of microprocessor from where the microprocessors have been arrived. Okay, so we will see the origin of microprocessor. So it is not actually important. Just have a look on the history for what is first generation, second generation, and third generation microprocessor. Okay, so first generation was a uh, 4-bit processor used in calculators in 1971 1972. Okay, second generation from 1973 to 78, they had improved performance and supported 8-bit processing. Okay, so if we see the example of first generation, we have Intel 4004 microprocessor. In the second generation, we can see that it is Intel 8008 and 8080 were introduced, right? And in third generation from 1978 onwards, the release of 8086 marked the start of the 86 architecture. So it was a 16-bit and laid the foundation of modern computing. Okay, got it? So first generation was just 4-bit microprocessor used in calculator. Second generation, 8-bit processing support. Okay, and in third generation, we find that 16-bit processors were introduced. Okay, so now let us have a look on the classification of microprocessor. So microprocessors can be classified based on word length, like we have seen the data length. Okay, so word length is of 4-bit for Intel 404 4004, 8-bit for 80 Intel 8085, and 16-bit for 8086. Okay, so from this point we can get a difference difference between 8085 and 8086 microprocessor, which is 8085 is a second generation microprocessor with 8-bit word length, and 8086 is third generation microprocessor with 16-bit processor, right? And then we have Pentium series, which is of 32-bit, and modern 86 processors are of 64-bit word length, right? Okay, got it. Now we have instruction set architecture. So RISC and CISC are the two types of instruction set architecture. Reduced instruction set computing, we have already learned about this in our previous classes, previous semesters, like in computer science and operating system, right? We have learned this, what is RISC and CISC and what are the differences between these two type of instruction set architecture. So RISC is reduced instruction set computing and CISC is complex instruction set computing. Let's move ahead. No, we should not waste time to discuss these things. Now, applications, general purpose processors, embedded processors, DSP, digital signal processor. These are the applications of microprocessor. Now, let's have the differences between 8085 and 8086 microprocessor. So, first of all, yeah, we discussed that 8085 is 8-bit microprocessor, 8086 is 16-bit microprocessor. Address bus, obviously, when 8085, it is 16-bit, which is 64 KB memory, and 20-bit, which is 1 MB memory, right? And then we have data bus, which is 8-bit and 16-bit according to the word length. Instruction set, 8085 is simpler and 8-bit instructions, while 8086 is more complex and supports 16-bit instructions, right? Clock speed is up to 3 MHz for 8085, up to 10 MHz for 8086. Number of registers, fewer general purpose registers for 8085. But while in 8086 microprocessor, we use so many number of registers as compared to 8085, and it is also having advanced features. Then we see the architecture. So 8085 is single accumulator based architecture, while 8086 is segmented memory architecture. Then if we talk about the modes, then it operates in single mode, while 8086 supports minimum and maximum modes. Okay. Hmm. Now, now let us see the architecture of 8086 microprocessor. So first of all, it consists of two functions, which is BIU and execution unit. Bus interface unit handles all bus operations. Bus interface unit interacts with, like, it is interacts with bus, so it all handles all operations like addressing, data transfer, instruction prefetch, etc. And it also contains segment registers like CS, DS, SS, ES, instruction pointers, and address generation logic. Now if we talk about the execution unit, it is responsible for the execution of instructions fetched by BI. Okay, so BIU used to fetch the data, and execution unit executes the data. Now, bus interface unit, as the name suggests, it connects the bus. Okay, different types of bus we have studied, like data bus, address bus, and memory bus, right? A control bus. So these different types of bus are connected through bus interface unit, and through which it can handle all bus operations like addressing, data transfer, instruction prefetch, all these. Okay, and then these instructions are executed through execution unit. So executes instructions fetched by BIU. Contains general purpose registers like ALU, general purpose registers, then ALU and flag registers, and the instructions decoder. So yeah, we have seen two functional units of 8086 microprocessor. Now let us see how the registers are organized. So we have general purpose registers, segmented registers, pointer registers, index registers, and flag registers. So general purpose registers are AX, BX, CX, DX divided into AH, AL, BH, BL. What is this AH, AL, and BH, BL, and all more like CH and DH? Okay, so this is actually when we talk about general purpose register AX, it is classified into AH and AL, where H and L means high and low. So A high and A low. Okay, similarly for BX and CX. Okay, then segment registers we have CS, DS, SS, and ES for segmented memory. Then we have pointer registers like SBBP and index registers SIDI. Okay, pointer registers SBBP. Okay, index registers SIDI, and flag registers reflects the status of the processor after arithmetic and logical operations are performed. Okay, now let us see the pin diagram. So 8086 has 40 pins divided into groups of address, data, control, and power. It operates in minimum mode, single processor mode, and maximum mode for multiple processor systems. Okay, now let us move ahead to the memory organization of 8086. So segment register, segmented memory. So 20-bit address bus allows access to 1 MB of memory divided into 4 segments: code segments, data segment, stack segment, and extra segment. So what was this we were talking about earlier? So this is the same thing. Segment registers include CS, DS, SS, and ES. Okay, got it. Each segment is 64 KB, and the segment offset addressing mode format is used. Now, clock generator. So 8284 clock generator provides a clock signal for 8086 and other peripheral. It also provides a ready signal to synchronize slower peripherals with the microprocessor. Now, buffers, latches, and transceivers. So, buffers temporarily store data to manage the flow between components. Latches hold data while controlling access to memory or input-output devices, while transceivers are bidirectional data transmitters often used for data buses. Now, let us move ahead to bus controller. 8288 bus controller manages the control signal required for 8086 operations in maximum mode. Okay, so 8288 controller manages the control signal. As the name suggests, bus controller, it will help in the in controlling of the signals required for 8086 operation in maximum mode. Because in minimum mode, already uses single microprocessor. But in maximum mode, we use different types of operations too. So bus controller is basically used to control the signals required for maximum mode. Okay, operations in maximum mode. It generates control signals for memory and input output access. Now, maximum and minimum modes. So, minimum mode for signal processor systems, the 8086 itself generates all control system, while in maximum mode, multiprocessor system and control signals are managed by external controllers like 8288. Yes, okay. Hmm. So this was what we. Let me conclude one by one everything, and you will be okay with this topic. So first of all, we have seen the introduction. What is microprocessor, which is a CPU on a single integrated IC. Okay, it performs operations like arithmetic, logic, control, input, output. Okay, and then we have seen the history. Okay, 8085 is a second generation microprocessor. 8086 is a third generation, and onwards there are 16-bit processors and 64, so many. Okay, then we have seen the classification of microprocessor based on word length, instruction set, and applications. Okay, then we have seen the comparison between 8085 and 86. So these are some. Let me just remind you that 8085 is 8-bit, while it is 16-bit. Address bus is 16-bit, 20-bit, 8-bit, 16-bit. And 8085 is simpler, 8-bit instructions, while it is more complex, 16-bit. And then we have the modes. It operates in single mode, while it operates in maximum and minimum modes. When it is in minimum mode, the microprocessor itself perform all the operation. But when it is in maximum mode, then we need external controllers like 8288 bus controller, which also helps in the performing of operations, right? Then architecture of 8086. So we have bus interface unit and execution unit. Then we have register organization where in the following ways. So general purpose registers, segment registers, pointer, index, flag register. Okay, then we have pen diagram where single processor mode and multiprocessor systems, right? Then we have segmented memory. So we have discussed about this 20-bit address bus allows to access 1 MB of memory divided into 4 segments, right? Then we have clock generator. So 8284 provides a clock pulse. Provides a clock signal for its and and other peripherals. It also provides radio signal to synchronize lower peripherals with the microprocessor. Then we have buffers, latches, and transceivers. So buffers, latches, and transceivers. Buffers store temporary data, latches hold data, and transceivers are bidirectional data transmitter used for data buses, right? Then bus controller and minimum and maximum mode. And after that, this is all we have, and I will be explaining all other topics tomorrow. For now, I want to take rest. So thank you. I hope you understood whatever I have told you. Thank you for listening me at all till then.